Hello students, welcome to Learner's Planet Theory Session 10 of Metals and Non-Metals. So it has been quite long we are dealing with this topic. Now this would be our last session of Metals and Non-Metals. In this session children, we will be discussing about the refining of metals. In our previous sessions, we discussed about the extraction of metals. Now, by all the processes we discussed, we have obtained a particular metal in our hand from its ore. Now, this metal has to be further purified for minor impurities. The metal which is obtained by all the processes is 95% pure. That's it. Still, there are 5% impurities which has to be removed. So in this session, we will be discussing one of the most important process for the refining of metals. Refining of metals. The metals produced by various reduction processes contain impurities which must be removed to obtain a pure metal. Now the most widely used method for refining impure metal is electrolytic refining. Electrolysis, I have already defined children. What is it? That is passing electric current through the electrolyte with the subsequent movement of positive and negative ions to the negative and positive electrodes. Now why it is called as electrolyte? Because on passing electric current it gets dissociated. That is why it is called as electrolyte. Any salt solution is an electrolyte, like sodium chloride, like copper sulfate, like ammonium sulfate, like ammonium chloride, aluminum oxide, aluminum chloride. So any salt solution is a electrolyte. But children, remember, covalent compounds like glucose, alcohol, benzene, cyclohexane, these are not electrolytes. These do not conduct electricity. Now let's see the refining of copper. How it is done. We have obtained copper by its reduction with carbon, that is by smelting. Now that smelting is done in Bessemer converter and that process is called as Bessemerization. Now the copper obtained after that is impure. It still contains the impurities of metals like gold, silver. Now that has to be removed. Now how it is done? It is done by electrolysis. Now in this case, the electrolyte taken is the solution of acidified copper sulfate. Now it is always done children. For whatever metal, the electrolytic refining has to be done. The electrolyte is its salt solution. And your anode is what children? Which electrode is anode? Is it positive or negative electrode? Which is anode? It is a positive one. So the impure copper rod is made as anode. And what is cathode children? Cathode is the strip of pure copper. That is thin strip of pure copper is made as cathode. So if I have to draw this electrolytic container, what it would look like. So children, it would be, say this is a thick block of copper and that is made what? That is made an anode. And this is what? Anode. And a thin strip of copper is made what children? It is made as cathode. Okay. So this is what? This is cathode. That is thin strip of copper. This is what children? This is anode. That is what? Impure copper rod. And what is the electrolyte here? It is copper sulfate. Now children, what will happen to copper sulfate? When I am passing electric current, what will happen to copper sulfate? Your copper sulfate will get dissociated into what? Here. Within this, what will happen? This CuSO4. This will be dissociated. And what on all ions it will give? It will give Cu2 plus SO4 2 minus ions. Now let's see the process how it happens. That is, on passing electric current through the electrolyte, pure copper dissolves from the anode, right? Or pure copper from the anode dissolves into the electrolyte. What was our anode? Anode was a thick impure copper rod. From that, the copper dissolves into the electrolyte. And an equivalent amount of pure metal from electrolyte is deposited on cathode. Now let's see the reactions, then it will be clear to you. Like at cathode, the positively charged copper ions from copper sulfate solution go to the negative electrode, and by accepting electrons from cathode, what they do? They get reduced to copper atoms. Fine, I told you that your copper sulfate, what happens to the copper sulfate? On passing electric current, it dissociates, forming what? Copper ions and sulfate ions. So CuSO4. On passing electric current, what has happened to it? It gets dissociated, forming what, children? Cu2 plus of SO4 2 minus ions. This is a sulfate ion. Now, what is happening to these copper ions? These copper ions will take up what? Electrons. And they will get reduced to copper atom. Now, as it is positively charged, to which electrode it would go? It would go to the negative electrode. Now, what was our cathode, children? Cathode was a thin strip of, it was what? It was a thin strip of pure copper. So what will happen? This copper will keep on depositing on this thin strip. So at the end, what will happen to the thickness of the strip? It will become thicker and thicker. Now let's see what happens at anode. At anode, anode is what, children? It is a positive or a negative electrode? Positive electrode. So copper ion atoms from impure anode lose 2 electrons to the anode, forming copper ions. So here what is happening, children? Here it is losing 2 electrons. So what is the sign to be put here? It is minus. So your copper, that is which is present in the impure rod, will lose 2 electrons and move to the electrolyte. So the copper ions are taken from the copper sulfate solution at the cathode and given to the solution at the anode. So children, this is the way how the electrolysis is carried out. So at the end, what will happen? Anode will become thinner and thinner, right, as the process proceeds or as the electrolysis proceeds. So your anode will become thinner and your cathode, what will happen to the cathode? As on the cathode, your metal is being deposited. So cathode will become thicker. Now what will happen to the impurities, children? Whatever was the present, I told you that the impurities of silver or gold are present. So what will happen to the impurities? The impurities will settle down as anode mud. Now during this process, impure anode becomes thinner and pure cathode becomes thicker. Now the soluble impurities go into the solution. Whatever is soluble, so if there is arsenic impurity, it will go. If there is any other impurity like phosphorus or any other element, it will go into the solution. Whereas the insoluble impurities settle down at the bottom of electrolytic cell. Now where it will settle down? Below anode. As it is settling down below anode, what is it called? It is called as anode mud. Now this anode mud contains metals like gold and silver. Now this gold and silver metals can be recovered from anode mud. So this was one of the very important process for refining of metals. So this many methods or processes are there in your syllabus. And we will be discussing this metallurgy in details in your 12th class. So you need to do this much only for metallurgy, right? There are few more refining processes which you don't need to do, you don't go into that. Now let's see the corrosion, one of the important aspects. We discussed corrosion in the chapter of chemical reactions and equations also. Here we will be discussing how to protect a metal from corrosion, or how to prevent corrosion. Now just to revise, I'll tell you, corrosion is an oxidation reaction with atmospheric oxygen in the presence of water. And where it takes place, children? It takes place on the surface of metal. So iron is the metal which corrodes very fast, whose corrosion rate is very fast. Iron, when exposed to moist air for a long time, acquires a coating of a brown flaky substance. Now that brown flaky substance is called as rust. Right? You must have seen iron objects which are left for a long time exposed to moisture or air, that brown dust-like particles are formed there. So that which can be easily rubbed off. So if we keep on rubbing that surface, again fresh iron is exposed. Again that hydrated iron oxide is formed. Then we'll again rub it. But it is a continuous process, and what happens that at the end of the process, the metal becomes thinner. Now this iron corrodes more quickly than most other transition metals to form an iron oxide. So what is the formula of the rust here, or the substance which is formed? I have told you, I'll again write it, Fe2O3XH2O. Right? So this is the substance which is formed on the surface of iron. Now this corrosion or rusting of iron is accelerated in the presence of carbon dioxide and also in the presence of salt solution. If there is a salty water or there is a sea water, what happens that the corrosion or rusting is accelerated. Now children, this corrosion is a continuous process that slowly eats up the entire object. So apart from iron, there are few more metals which get corroded, like silver. Silver articles become black after some time when exposed to air. Now this silver is not a reactive metal, right? It doesn't react with oxygen of air. What it reacts is, it reacts with sulfur in the air to form silver sulfide. Now there is a metal like aluminium. Aluminium is a metal which is resistant to corrosion. So aluminium is resistant to corrosion. Why? Why is aluminium resistant to corrosion? What happens that aluminium reacts with oxygen of air and it forms a layer of aluminium oxide. So a layer of aluminium oxide is formed. Now this is a protective layer which is formed over aluminium metal. Suppose this is your aluminium metal. This reacts with oxygen, forming a layer of oxide here. This is an oxide layer. Now children, this metal is no more exposed to oxygen, or metal is no more exposed to the moisture. So it becomes resistant to corrosion. Now in order to protect this aluminium, what is done is that the oxide layer is thickened. Now let's see few more metals which get corroded. Here it is copper. Copper reacts with moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. Right? Now what is that green coating of? This green substance is basic copper carbonate. What is the formula of this? Copper carbonate. What would be the formula, children? It would be CuCO3. And it is basic also. Means there has to be hydroxide. So it would be CuOH whole twice. So children, this is the substance which gives the green coating to copper. This is the substance. So this is how copper gets corroded. Now let's see how we can prevent corrosion. There, iron is a very important metal. It is used for construction purpose. Even it is used for as a steel, steel is an alloy of iron. How could we protect it? Your bicycles, scooters or automobiles, they are all made of iron. So if iron gets corroded, or it will go on corroding, or it will go on rusting, what will happen? Your bicycle layer, or the layer of the iron present in the bicycle, will become thinner and thinner. How it is protected? This is by painting, oiling or greasing. Iron or steel. Steel is what, children? Alloy of iron. It is protected by paint. Now what this paint does? What is the function of paint here? The function of paint is that it provides a barrier between the metal and air or water. So what it is doing, children, it is providing a barrier between the metal and air and water. So what is the result of this? That your metal is not exposed. Exposed to what? Exposed to air or moisture. And so what is happening? Your metal is protected. Now children, the utensils, they are made up of steel. We can't paint it. We can't grease it. We can't oil it. Why? Because when we will heat it, when we will heat the pan, what will happen? That oil will come out. So it is coated with some other metal, like tin or any other metal. Now let's take some other method. This is sacrificial protection. Sacrificial, as the word indicates, that the other metal is being sacrificed. Like rusting can be prevented by connecting iron to a more reactive metal. So we know, on the basis of the reactivity series, we know that the zinc or magnesium are more reactive than iron. So if we are coating iron with zinc or magnesium, what will happen? That your zinc or magnesium will get oxidized. So what is going to get oxidized here? It would be zinc and magnesium and not iron. Now this is referred to as sacrificial protection or sacrificial corrosion, because the more reactive protecting metal is preferentially oxidized, leaving what? Leaving the protected metal intact. So this is what, children? This is sacrificial protection. Let's see few more methods. Alloying. Alloying means alloys. What are alloys? These are the mixture of two or more metals. So what is an alloy? Alloy is a mixture of two or more metals. Like iron or steel, along with other metals can also be protected by alloying or mixing with other metals. How? Like chromium, like nickel, like copper. So all of them are mixed in a proportion so that the metal is protected. Like your stainless steel. Stainless steel is an alloy of iron, chromium and nickel. What is the percentage? Iron is, children, 74%, chromium 18%, nickel is 8%. Now it is an example of a non-rusting alloy of iron. Likewise brass. Brass is an alloy of copper and zinc. There's no that green layer formation doesn't happen in brass. Bronze. Bronze is an alloy of copper and tin. Likewise your solder, the metal which is used for soldering, it is an alloy of lead and tin. So children, alloying is also one of the methods by which we can prevent rusting of metals. Now let's take a few more methods. This is galvanizing. Now what is galvanizing? This is coating iron or steel with a thin zinc layer is called galvanizing. Now we know, children, that zinc is more reactive than iron. So what is done is that if I have to draw an iron object, say this is your iron object. Now how I can protect this iron object? I can protect this iron object by covering it with a layer of zinc. So there is a layer of zinc over it. Now what will happen? Which is more reactive? Zinc is more reactive. This is what? Zinc. Now this is more reactive than iron. So zinc is more reactive than iron. So what will happen? What will happen, as it is more reactive, zinc will get oxidized and not iron. Now how this galvanization is done? Galvanization is done by dipping an iron object in molten zinc metal. So molten zinc metal is taken, and to that this particular, suppose iron object was there, it is dipped in zinc. As a result of which what happens? A thin layer of zinc metal is formed on the surface of iron object. Now this protects it from rusting. A thin layer of zinc metal on the surface of iron object is formed, which protects it from rusting. How? The zinc being, let's see how it protects. Zinc being more reactive corrodes or oxidizes to form a zinc oxide layer. That is, your zinc will react with oxygen and it will form what, children? It will form zinc oxide. So what it is going to form is zinc oxide. Now in place of zinc, which was there over the metal, what layer will be formed? Zinc oxide layer. Now zinc oxide does not flake off like iron oxide rust. What I told you was that rust or iron oxide is deposited on the surface of iron, and if you rub it, that flakes off or that falls off. But in this case, children, the zinc oxide cannot be flaked off. Now this galvanized, so the zinc oxide layer, what it will do? It will protect the layer of zinc which is below it and also the iron. So galvanized iron object remains protected against rusting, even if breaks occur in the zinc layer. See what happens if there is a break in the zinc layer. Right, say I took this cone here. So this is your iron object and we have got a layer of zinc over it. Now this much has been broken. Now what will happen, children? This particular layer is broken. I'll mark it with a different color so that it's visible. Say here this particular layer is broken. Now what will happen? That your iron is exposed, so it should get oxidized, but it doesn't happen. The zinc which is present in the surroundings gets oxidized, right? And still this iron is protected. So zinc here is more easily oxidized than iron. There are few more methods by which your metal can be protected. One of them is electroplating. Have you heard of this? Electroplating. In this, what happens, children? In this layer of like tin or chromium is put over the iron object, right? That is, iron is plated. Plated with what? Tin or chromium. And what happens here is that your tin gets oxidized and iron is protected. Likewise, chromium gets oxidized and iron remains protected. You must have seen your bicycle, how it shines when it's new. Why? Because of the plating of chromium over it. So, because of the plating of that chromium, your bicycle shines. And slowly what happens? That layer removes off, that layer gets oxidized, or the shine gets over. Then it has a dull appearance then. Your tiffin boxes are electroplated with tin, because tin is not poisonous, right? And neither it harms the food. So your tiffin boxes and other utensils are plated with tin, and our very high quality utensils are plated with chromium. So these are certain methods, children, by which we can protect a metal. So these are the concepts for your metals and non-metals. Now it's your part to practice equations, to just by heart the properties of metals as well as non-metals. This completes your sessions of metals and non-metals. Now then, after this we will be solving questions on this topic. Okay? So children, thank you very much for your patience. Thank you very much for listening patiently. We will be meeting in our next session for solving problems related to metals and non-metals.